Hello everyone, welcome back. We have seen different videos on the concept of limit of let's see, introduction to limits. In this chapter, we have seen a lot of videos about sequence property, convergence versus divergence. But now we will see about convergence with perfect example. So please like, share, and subscribe to our channel. Let us go. Example 1. Find the limit of each of these convergence sequences, which is, as we have seen before, there are two properties in convergence. The one may be convergent or divergent. So how can we differentiate the limit of the sequence which is convergence or divergence? Let's see. Our function is this. This is our function. Yes, our limits of sequences. For this limit of sequences, to find convergent, to find whether it is convergent or divergent, and if it is convergent, to what numbers it converges. So we cannot use the quotient rule because neither the limit for the numerator nor that for the denominator exists. Yes, because we cannot use the quotient rule. Why? As you can see, the numerator is degree 3, the denominator is degree 2. So when we use a quotient rule, it is f of x over g of x. F of x have to be highest degree than the g of x. Otherwise, there will not be the quotient rule. So this is n the power of 2, and the numerator is n the power of 2, and the denominator is n the power of 3. So the denominator has the highest degree than the numerator. So we don't use the quotient rule for these types of limit. On the other hand, we can divide the numerator by denominator by n cubed, and then use the linearity rule and the product rule. We then have our function this n square minus to the power of n plus 3 over 5n cubed. When we simplify this, we we will differentiate it's 1 over 5. Yes, we will take 1 from the numerator and 5 from the denominator, so there will be 1. Yes, this is 1 over 1 times 1, this is 1, 5 times n, 5n, minus this is 1 over 2, and 5 is n square plus 3 over n cubed. So we can see this, as you can see from this, n square over 5n cubed, which is 1 over 5n, minus this is 2n over 5n cubed. 2, this is n, this is n cubed, so it will be n square, as you can see from this. So there is 2 in the numerator, and this is also 2 in the numerator, plus 3 over 5n cubed. So we will put 5n cubed as it is, so 3 over n cubed. So we have 1 over 5 as a common term for all of those simplified form of these limits. Then when n goes to infinity, which may be 100, yes, and greater than, it is our domain is all natural number, which is starting from 1 up to infinity. So we can use any types of numbers for those, and when we insert each numbers for those values, it will approaches to 0, because when we take highest numbers in the denominator, it will approaches to 0. So n approaches to 0 as n approaches to infinity, or n goes to infinity, the sequence or the limit approaches to 0. We can use 1 over n, 1 over 1000 is 0 0.0 something, minus 1 over n squared. N is equals to, let's say this is n equal to 1000. So 1 over 1000 for this 1 over n, 1 over 1000, it is 0 0.001 minus 2 over n squared. N is 1000, so 1000 times 1000, it is 100,000. So 2 over 100,000, which is approximately 0.0002. It's something like that, plus 3 over n cubed. So when we make it cubed, the power of cubed, it will be million. It's approach to yes, it's million. So 3 over n cubed, it is 3 times in the power of minus 7 or 8 something. So it is almost approaches to 0. When we, this is only for n equals to 1000. When we take n equals to 10,000, it will absolutely approaches to 0, which is 10 to the power of yes 20, negative 20, or something like that. So this value is approaches to 0. So we have 1 over 5 commenter for all of those values. So 1 over 5 times 0 is equal to 0, because every number multiplied by 0, the result will be 0. Every number multiplied 1, as we all know, the number itself. So n approaches to 0, n approaches to infinity, all the sequence approaches to 0. So this is the convergence sequence, because it converges to a single number, which is n as which is 0 as n goes to infinity. This is all about today's example. I hope you have get some valuable information or knowledge from this video. If you like it, share for your friends and subscribe to our channel. Thank you.